In this demo, we're going to be showing you how environment lighting works in Relight. So to show you environment lights, we're going to bring up our patient character. The patient character is composed of a polygonal mesh for the head, a fur object for the hair. And the way environment lights work in Relight is they are a light source like any other light source. In Relight, anything which creates light is a light source. So here is our shading tree for the lights in this scene. For the moment, they're just one, the environment light. And what we're going to do is attach a texture map to the color input of the environment light. We're going to specify that it's a spherical environment map, so that it will be mapped correctly. And environment lights are based on point clouds in Relight. So what we're going to do is create a point cloud for the environment light. First we have to rasterize, as always. And to simplify the computation, what we're going to do is when we compute the point cloud for our environment light, we're not going to take into account the hair, because we don't need that sort of high frequency detail. So we're saying here that the environment light only sees the head and the body of the patient, not the hair. And later we'll add ambient occlusion for the hair using a different viz group which sees only the hair. But so for now we're going to turn off ambient occlusion and show you just how the environment looks without ambient occlusion. So we're computing the point cloud for the environment light, and that's what it looks like. As you can see, there's no hair because we don't need it, and it's cheaper to compute without it. And then we compute it. This is showing you just the intensity of the environment light. And you can see that the hair doesn't look good because there's no self-shadowing. So that's why we need to turn on ambient occlusion. So for the ambient occlusion shader also we're going to need to compute a point cloud. As I said, this point cloud only contains the hair, nothing else. So you can see the point cloud was adjusted to have a certain amount of transparency. Now we hooked up the ambient occlusion to the intensity of the environment light. We recompute, and this is what the intensity of the environment light this is the intensity of just the ambient occlusion shader. The intensity of the environment light looks like this, and when we shade, that's the final result. Now what we're going to do is to add an additional light source. Oh no, not quite yet. First we're going to play with the specular diffuse intensity. It's very quick once it's been computed once. Modifying parameters is very quick. Okay, now we're going to turn on another light. It's a spotlight, which we call a rim light. It's a spotlight placed behind the character, and it's just going to highlight the side of his face. That's the intensity of the spotlight. Now we're going to add a shadow map. So compute shadow map, reshade. Well, that's the shadow map. And this is what the intensity of the spotlight with the shadow map looks like. So now we're going to go back to our shader tree, put back the environment light as well, and you can see the contribution of the spotlight with and without the spotlight. Now what else can we do? What we can do in the 3D view is we can take the, if we turn on the 3D manipulator, we can actually manipulate our environment light interactively. And since we turned on automatic refresh in the render view, you can see that as we move the environment light around, the image is automatically re-rendered. You can also put a different image entirely in the map which is used for the color of the environment light, and the lighting is recomputed quite quickly. There again we can change the position and the image is re-rendered. Now this is the shading tree for the material used for the skin. You can see there are several different shader nodes. It's a mask node, specular map, color map, bump map. And so we can see the contribution of each of those shaders individually. And here we're playing with the saturation of the color map node. And what you can see, what's interesting here is that as we play with the saturation of the color map or the specular map, the image is recomputed very quickly because the environment lighting and ambient occlusion have all been computed. They don't need to be recomputed when we change the material parameters. So it's very fast. Now here we're going to do the same thing with the material which is used for his hair. We can play with the hair colors, the color at the root of the hair, at the tip of the hair, the specular, and again we've turned on automatic refresh in the render view, so every time we modify an attribute, the image is re-rendered, and it's re-rendered very quickly.